All right, greetings everyone. Welcome to the fourth part of the video for section 8.2. And as promised in the previous video, we'll now start looking at graphing polar equations on our calculators. So we're going to start by graphing this equation, r equals 5 sine theta. So I'm going to switch over to my calculator view here. And here's how we go about graphing this. First of all, we need to check our mode of our calculator, so click that. And we want to go down and make sure we're in radians for this. And then right below that, you'll notice that there's a line that has polar as one of the options. And so this line allows us to kind of change between different modes and different types of variables we might use to graph those modes. So since we're doing things in polar equations, we want to take this off a function and scroll over to where we see polar and press enter. So we're now in polar mode. We can quit out of that. And then if we go to our graphing apparatus now, you notice that instead of having y equals, we now have r equals. Okay. And so we can type this in, that equation we just saw, 5 sine theta. And when we hit graph, we can see what the graph of that looks like. In this case, we get something looking like this, which is supposed to be a circle, even though it looks kind of like an oval. And so we can fix that if we hit zoom, and then number 5, it'll kind of square everything out. And we see that it is, in fact, a circle. Okay. Now, we can also graph these sorts of things on Desmos if you're using that or another online program for your graphing. So let me show you that. Pull this up here. All right, and here's how we can graph these in Desmos. Is we basically just type in what it is we want to graph. So here I could do r equals, since my output variable, remember, is r. We're doing 5 and then sine. And then for theta, we can actually just type in the word theta, and it'll do that for us. And you'll notice that it gives us the picture there. Okay. And so that's how we can graph these using Desmos. Cool. All right. So let's look at some other things we could graph. So these here, 6 cosine theta plus 3, r equals 6 cosine theta plus 3, and r equals 4 sine theta plus 2. I'm going to graph the 6 cosine theta plus 3 on the calculator. So let's take a look at that. So go back to our y equals or r equals. We'll put in the 6 cosine theta plus 3. And then we'll graph it. And you'll see we get this kind of interesting looking circle with a little loop-de-loop on the inside there. Okay. And if we were to graph the other equation, we would see something similar. And in fact, if I go back to my PowerPoint, go to the next slide, notice now I have the graphs of both of those. And I want you to notice some things about these. So number 1, notice that in the first equation, the trig function we see is cosine. Okay, which if you think about on our unit circle, cosines are x values. And notice how the graph itself down here is kind of centered on the horizontal or the x-axis. In the other equation, notice that we have a sine value. And we know on a unit circle, sine values are y values. And notice how this graph here is centered on the vertical axis or the y-axis. So we see there's some connection there. Also, if you notice the answer, the number being added to the end of each of these, so the +3 and the +2. Well, if you look at kind of the length of this little inner loop, in the first one here, it goes out to a value of about or exactly 3, and there's a +3 on the end there. And on the other one here on the inner loop, we see that it goes out to 2, and there's a +2 on the end there. Okay. And so these cool little loop-de-loops here, these are what are called, and I don't speak French, so please pardon the mispronunciation here, but limaçons are the names of them, okay? And you can see kind of the 4 different possibilities here, their basic shapes. For the 2 on the left there, you see they involve cosine, and they are along the horizontal axis. The 2 on the right there, those 2 forms involve sine, and they go on the vertical axes. Okay, so those are limaçons. And I'm not so concerned with you knowing the name or knowing the exact formulas, but just be aware that this is how these work. Another special type of polar function you might see are these: r equals sine 2 theta and r equals cosine of 4 theta, or it just really sine or cosine of anything times the theta on the inside. And what these give us are these cool looking pictures. And can you imagine what these are called? Right, they kind of look like flowers, and these are actually a special type of flower. They're called roses. Okay, so this is what we call a rose. And you'll notice a couple things about the roses. First of all, here, notice that if we look on the number being multiplied by the theta on the inside and count the number of petals of the rose, so here this one has 1, 2, 3, 4, which is double the 2 here. Here with the 4, we see we have 1, 2, 3, 4, 5, 6, 7, 8 petals, and there's a 4 on the inside. So it looks like there's some sort of relationship where the number of petals is double that number on the inside. And that in fact works for when we have even numbers, so the n equals 2 or the n equals 4. But if it's an odd number, like we see here with n equals 3 or n equals 5, and you count the number of petals, well, it turns out that that's exactly the same number. So here, if we had something like, say, sine of 3 theta, we would have 3 petals like this, or sine of 5 theta, we would have the 5 petals like this. Okay? All right, that's it for now. Thank you for watching.